The weather's good today. I feel kind of hungry.
I don't have an appetite right now.
You don't have an appetite? Why?
No, because we haven't done our Hendricks homework. It's due this week. On
Wednesday? Oh, damn. Yeah,
Oh.
let's go pick up some people to help us.
Alright. I know it's just the right people. Hello?
Yo, man.
Yeah, we're coming to pick you up right now.
Alright.
Hey! It's our neighborhood. How are you, bro?
Hey, how are you? Get in the car, come on, let's go. We have one more person to pick up. Did you put the location for the next one?
Oh, guys, how are you, man? This
Good,
one's quite
good.
far.
This one's quite far away.
Yeah,
Where's it live?
don't worry.
Sim?
Yeah.
Yo, that's him, bro.
Hey!
Get in, bro, get in. How are you?
What's up, man?
Come on, we have chemistry to do. Open the door, is it this one? Okay.
Yo, bro.
What's up, man?
man? How are
Dude,
you?
how are you? How are you? You look good. Do you want to sing something?
Yeah.
Do you want us to play some music?
You guys into some juice work?
I was thinking more of
About to work, cause we're tangled in a daydream. We on a new wave. Feel like a moment, weight on my shoulders. Baby, would you stay with me? Yeah, that's what I told her. Trying to run out of season, but I can't stop. Didn't think it was rocking me, then straight up. Sling it, hold it. It's a straight pop. On my knees, got me praying like I can't stop.
Alright, I think we're good. 3, 2, and 1. What's up, guys?
Hey guys, so we're all familiar with enantiomers. In the medical field, they can be very annoying. Making medicine is already a complicated process, however we need them to prolong and sustain our health. Without knowing, we've already learned some of the basics of understanding on synthesizing them.
But luckily for us, we don't even need to know that much. We've already learned mechanisms this year, and that helps us understand how a reaction actually occurs. But sadly, some of us just memorize it for the sake of it.
No, actually all of us. Well, we can put this into perspective. We're going to go over 2 different examples. The first one, all of us have consumed it at some point in our stage of our lives. Usually your mom would give it to you when you got sick. If you guys haven't guessed yet, I'm talking about ibuprofen. We chose this substance specifically because in the synthesis of ibuprofen, you produce 2 different products, and this is where the understanding of mechanism comes in.
But linking to what we've already learned, let's talk about the reaction of hydrogen cyanide and an aldehyde. I'm going to give an example, ethanol. Ethanol is already a planar molecule. Therefore, a nucleophile will attack the planar molecule equally from both sides, resulting in 2 products formed. And these 2 products formed, in this case, is an enantiomer of one another. And as you may know, reactions of one enantiomer can be different to another one due to the different molecular arrangement. And this can be very bad for medicinal fields because one enantiomer can have positive effect, however, due to the different reaction, another one can cause a negative side effect.
Well, we've mentioned that ibuprofen produced 2 different products. This is just more of an additional information for you guys to have a better understanding. In the synthesis of ibuprofen, a primary carbocation is formed. However, it is converted into, it rearranges itself into a secondary carbocation as it forms a much more stable molecule. Thus, you have 2 different carbocations that will react with the benzene to form 2 different enantiomers of ibuprofen. Fun fact, ibuprofen is sold in its racemate mixture, but we've discussed that one enantiomer can have negative effects. So why is that they sold in its mixture? Well, your body contains an enzyme that is able to convert the inactive form into its active version.
So just to summarize the spec point that we've been talking about, understanding mechanisms is very important as you want to avoid producing the unwanted product to avoid the negative reactions that can occur in our body.
Well, in an industrial picture, by understanding these mechanisms, we can lower the expenses that goes into the production of these substances, as well as reducing the cost of separating the mixture. Asman,
Oh, yeah.
do you think you can stir up an experiment for us to visualize?
Oh, yeah, sure. Be right back in the next clip.
BBI part, please.
smells it.
Oh damn, man, this is sick!
What you made? Actually, what you made?
Yo, smell this, bro.
It's not lavender?
Yeah, man.
Wow!
Look at
Yeah.
that.
I think we can make it work.
Let's go try.
Let's go try it. Ben.
And that should be it.
I think that's lavender.
Dude, it smells weird.
Really?
Can you
Are
come
you
over?
sure?
What do you guys make?
This is...
Isn't it lavender?
Yo, that's not lavender, bro.
That's lavender!
Dude, look at the color difference as well, man.
It smells the exact same.
What is that?
Yo, so guys, so this is an example of people just doing whatever they want because they're told to do so. They do not understand the whole reaction, the whole mechanism. What they thought this experiment was going to be straightforward ended up being very complicated for them because this reaction ended up with this reaction involved enantiomers being formed, and what they made was an enantiomer that they didn't want, and like not make the one that they want.
I've fallen!
So fall.
Relaxing. Oh no, I'm drowning, guys. Oh,
I'll save you.
Oh no!
Whoa, what? We just appeared to
Fallen
the
as
tree.
well.
Guys, look, I'm hiding in the tree. Whoa. Oh, wait, my face is still there.
Bro, is that Shafik over there?
Yo,
I should Shafik.
quicksand! Oh, quicksand, help me!
Two products because a trigonal planar
Oh my god.
because a trigonal.
Planer.
Alright, I think we're good.
I say pass pencil. Hey. Hey.
Kimbo.
Alright, I think we're good. 3,
Don't ruin my hair.
2,